Good evening, coaches, or good morning, depending on when you're watching this video. This week we had transformed our commercial controller into a C# and a Go file. Sadly, I wasn't able to complete Go as I already had a lot of trouble with C#, and Go was so complicated. It blew my mind multiple times. This has definitely been the hardest week so far, but I still did the best I could, and I hope it paid off. So I'm gonna start off by booting up my scenarios right here in Visual Studio. So we'll open the terminal and voila. So as you can see, it works fine. The chosen column is 4, elevator 16 move down to user current floor, which is 54 in that case. Elevator 16 move down to requested floor 1. Elevator chosen is 16. And this is the second scenario. The chosen elevator is 1. Elevator 2 move down to user current floor. Elevator 2 move up to user current floor. Elevator 2 move up to requested floor. Elevator chosen is 2. So now to show you how this works, I'm gonna open VS Code as it's clearer that way in my opinion. So let's go back up, and as you can see, it started off with my battery. In here is where the request elevator function is happening, where the user calls an elevator, the program will understand and add the program will understand it. Then add the public column. It's to find the best column to be used by the user. Where is it? Well, it's there. Then if we move to our column class, which is the most complex, it starts off by our find best elevator function, which has a couple conditions, one for each column, so 4 conditions. The first one will set that if the user is at the same place as the elevator, it won't move and should just open its doors. If user is at floor 1, then it should hurry there as soon as possible, and if it's not at floor 1, it should look at the requested floor and get there. This logic applies almost the same way towards every condition. So the only difference would be that here it's only if user is at floor 1, if user is not at floor 1, whereas this would be, there would be another, how can you say? Another part of the structure. And this is what I'm gonna say. Um, so yeah, now to our elevator class being a bit simpler, which is down here. Our first function is about moving the elevator to the requested floor. It's easy. If the position of the elevator is higher than the requested floor, it'll have to go down. If position of elevator is lower than requested floor, then it's gonna have to go up until destination is reached. It's very, it's basically what we did from the last weeks, but just in different language. I did this function 2 times because for some unknown reason, I don't know why, but it didn't work if I only did it once. So I redid it with a different syntax, and now it works. Sorry for the stuttering tonight. My body is tired. Now the only thing left is class program, which I'll try to go quickly over. So here the elevator and column section is classed by their ID, their direction, their position, and their lists. Then it's gonna be the column that will be classed by their ID, their list 11 in column, their max floor, and their minimum floor. Then it's gonna be the batteries, which are right here, which will be classed by ID, their their number of column in battery, number of basement, and their list column in battery. And finally, ending my code is my scenarios. Of course, this is all the same in my Go language, which is right there. But the syntax is is wrong because I basically copied and pasted C# into this and changed everything I could change that I could have think of. I know some stuff is wrong. I think everything is my battery is good, But I know my column structure and my elevator has some major problems. I just can't pinpoint where they are. But yeah, apart from the fact that it can't run yet, that maybe I would have needed one more day and it would have worked. I think this is passable. So yeah, have a good night and we'll see you next week.